This is the video notes that are going to go with guided notes, recursive sequences, and terms. Now, we've already looked at how to write our formula for some basic geometric and arithmetic sequences. We've also talked about in part 2 of those notes how to find a particular single term. Okay, now we're going to switch gears here and look at a little bit different type of problem that comes with the recursive. Okay, if you look closely at the directions right here, it says write the first 4 terms in each of these recursive sequences. Now, our first example right here is going to be an arithmetic sequence. Okay, now, but I don't particularly have to know that because I've got all the information I need to know. I'm given the formula. A sub n, which is my current term or last term, is equal to a sub n minus 1, that's the term before it, plus 4. And my pattern is going to start at 1. Okay? So let's just organize our information. Just thinking about, we have to show some work, but we want to show work that is organized that people can read and follow. So to do that, I'm going to use a double T chart. Okay, I'm going to make this first column heading N. I'm going to make the last column heading A sub n. That will not change. Okay, what is going to fall right in here is what we used to call input-output rule. Is our recursive formula. It's this part of my formula. A sub n minus 1 plus 4. Now, I am asked...
-1 plus 4 is 3.
Sorry about that. Siri's trying to talk to me. I'm going to make my table. 1, 2, 3, 4. The reason I did that was because it said find the first 4 terms. First one, second one, third one, fourth one. Okay? Now, we're already given the first one because we're told right here that a sub 1 is equal to 2. So I'm going to put a 2 right here for a sub 1. And to show the work, all I'm going to write is given. We're told that. Okay? And anytime you're told something in math, you can just use the word given. All right? Now, let's talk about how I'm going to show the work here to do the second one. Now, remember, a sub n minus 1. That is the term that is before it. And if I think about this, that's 2 minus 1 plus the 4. But a sub 2 minus 1 is really just a sub 1 plus 4. Well, what's a sub 1? 2. So that's going to be 2 plus 4, which is 6. Okay? Now, let's go down to our next one. Again, a sub n minus 1, that's the one before it. So really what I'm going to do here is I'm going to take my a sub 2 answer, which is 6, and I'm going to add 4. So I've got 6 plus 4, which is 10. Okay, see how this is working? Now to find a sub 4, I'm going to take a sub 3 and add 4 to it. Well, a sub 3's answer right here is 10 plus 4, which is equal to 14. So to my first 4 terms are 2, 6, 10, and 14. Right there is my answer. And if you wanted to, you could take your circle it, highlight it, but right there is my answer. Okay? Now that is a very basic arithmetic sequence. Now let's go over here and let's look at a basic geometric sequence. I'm just going to make myself a little note. that this is a geometric sequence. Okay. Now, I'm going to organize myself again in a double T-chart, just like this. First column is N. Leave me a bunch of space to do some work. Second column is A sub N. Okay. What is the heading for my middle column? It's whatever the math is I'm doing. And guys, there's a little typo right there that's supposed to be an equals. Okay. Now, that means the work I'm going to do is A sub N minus 1 times 2 to the N minus 1. Okay, well, that's looking a little more complicated, but it's okay. It's not as difficult as it looks. So there's 1, there's 2. Notice I'm giving myself plenty of room to do work. I'm not trying to squeeze it because if you get all squeezed up, it's harder sometimes to make it, tell things apart, and you make mistakes. Okay? Now, the first term I'm told is 8. So right here for work, all I'm going to do is write down the word given. Now, my rule right here says A sub N minus 1. So if N is 2, that means I'm going to take A sub 1 and I'm going to multiply it with 2 to the N minus 1 power. Okay, so what my work is going to be, we'll see A sub 1, just substitute, that's 8. And then 2, now my N here is 2, isn't it? So 2 minus 1. Now once I get right here, I can actually put this into my calculator. Okay, I'll get my calculator right here ready. Remember where our exponent key is. It's that caret key right here, right above the divide sign. So I'm going to do 8 parentheses 2 caret 2 minus 1, because that's my exponent. Now, to get out of that, I'm going to hit the right arrow, and I can put my closed parentheses, and I come up with an answer of 16. Here we go. Now, probably a lot of you could have done that in your head because 2 minus 1 is 1. So it's 8 times 2 to the first power, which is 8 times 2, which is 16. Okay? Now, look at number 3 right here. We know this is going to be A sub 2 times 2 to the N minus 1 power. Okay, but what's my A sub 2 number now? 16, isn't it? So I'm going to bring it right here. 16 times 2 to the 3 minus 1 power. Well, we can do this one in our head too. 3 minus 1 is 2. So that's 2 to the second power. 2 to the second power is 4. 4 times 16 is going to give me 64. Again, if I need to, I can put it into my calculator right here. 16 parentheses 2 to the, well, 3 minus 1 power is just 2 parentheses, and it tells me 64. Okay, now let's do our fourth one. Fourth one is going to be A to the third, A sub 3, and then 2 to the N minus 1 power, just like that. Now, A sub 3 was 64, right? And that's 2 to the 4 minus 1 power. So what would I put into my calculator? I'm going to put in 64 parentheses 2 exponent. Now, 4 minus 1 we know is 3, so I can just put my 3 there. And I come up with 512. So again, right here is my answers, my first 4 terms. Right there. 8, 16, 64, and 512. And if we notice, that's multiplying by 4 each time, or multiplying by 2, okay? Or the power of 2, okay? Now, let's take a look at the next two examples. These two are a little more complicated. These are not simple. They are not simple arithmetic or geometric sequences, okay? These are going to be a little more complicated, so you really got to know how to organize your work to come up with the right answer. So again, my double T chart is going to be perfect here, okay? So I'm going to make my chart. And sometimes if we know we're just adding or subtracting a single number and that's it, we can do it faster without the T-chart. But sometimes you just got to have something a little bit more organizable because the work is a little more complicated. Now look right here. My rule right here is A sub n minus 1 minus 2n minus 1. And again, I'm looking for my first four terms. That's 1. This is 2. This is 3. And there's 4. And again, I'm giving myself enough room to do some work. Okay? When you start trying to cut corners on work is when you start making mistakes. Now, A sub 1, we're told that. We're told right here that it is 5. Okay? So again, that's my given. Now, what kind of work am I going to do? I'm going to do A sub n minus 1. So that's the previous answer, which is what? 5 minus, now 2 times n. But what's n? N is 2 right here, isn't it? Minus 1. Now that's the work that's going to give me my next term. You know, we can do this in our head. 4 minus 1 is 3, but 5 minus 3 is 2. Okay? Now, let's do our next one. Our next one up here says A sub n minus 1. That is our previous term, which is what? 2 minus 2 parentheses 2 times n, which is 3, minus 1. Now I can just chuck all of that into the calculator just the way I see it. And when I do, it's going to tell me -3. If I want to do it in my head, I can. Just be careful with your integer rules. Okay. Now let's go for our next one, our 4 term. Well, we've got up here where my thumb is at, our last term, which is -3 minus, you know what, I'm looking right here. I'm not supposed to have that 2 there. Take out that 2. I apologize. Making mistakes. Sorry about that. Now, 2 times n, which is 4 minus 1. So -3 minus 2 times 4 minus 1. Well, that's 8 minus 1, which is 7. So -3 minus 7 is going to be -10. Now, again, if I look, I don't see that I'm straight adding or subtracting the same amount each time. But that's not what makes it recursive. What makes it recursive is that I have to use the previous term to get my new term. Okay, so see, I started with 5, I used a 5 in the next step. I got an answer 2, I used a 2 in the next step. I started with -3 here and I used it in the next step. And then in the next one, I would actually use -10 to find the 5th one. Recursive means you use the previous term to get your new term. Okay? Now, number 4, again, it's not a traditional arithmetic or geometric pattern. It's not. Okay, but it is recursive. So we've now figured out that not all recursive sequences have to be geometric or arithmetic. All those you did in elementary school were, though. So setting up my table again. That. Now, what is the rule that goes right here in the middle? A sub n minus 1 times n squared minus n. Oh, I got me a good old exponent in there on this one. Now, let's go ahead and start. We know our first term, our a sub 1, that's 3, isn't it? So we're given that. Now, how am I going to find the second term? Look right here at my rule. A sub n minus 1, that's the one before it. So that's going to be my 3 times, now what's n? N is 2, so that's going to be 2 squared minus 2. Okay, so 3 times 2 squared minus 2, just little order operations in my head or my calculator, and I'm going to come up with an answer of 6. Now, let's try for the third term. Go back up here to my rule. A sub n minus 1, that's my previous term, so that's my 6. Parentheses. Now this time n is 3. So what am I going to write down? 3 squared minus 3. So 3 squared minus 3 times that 6 outside is going to give me a 36 for an answer. Okay. Now look at my fourth term right here. Let's go back right here. A sub n minus 1, it means I'm going to use the 36, my previous answer. And then I'm going to have, since n is 4, I'm going to have 4 squared minus that 4. And when I put all that in a calculator, and I did, y'all, because I just didn't want to do that much math in my head, I came up with 432. And again, right here are my first 4 terms. Okay. Now, again, just to reiterate, a lot of your recursive sequences are geometric or arithmetic, but sometimes they get a little bit more complicated than that. But remember, recursive doesn't mean you just add or subtract or multiply or divide. It means you use the previous term to find your new term. Your last answer gives you your next answer. Okay. Now, go ahead and make sure you have these notes copied into your notebook, and then you can return to Canvas and find your assignment that goes with these.